AP Stats. I am here at home answering the questions that you sent by email to help us prepare for our test on Wednesday. And I'm very proud of y'all for sending in the questions, and hopefully this will help you prepare. And I also went through and checked your answers to the video and the questions from last week, and was really impressed by your answers to the questions. Seems like you're getting down that four-step process, and then there's a couple things that you did on that I want to address really quickly as well. But first of all, our first question is, can you use Z star instead of T star for means? We know that we use the T distribution for means when we do not know sigma. When we have to estimate the standard deviation using the sample distribution to get S instead of sigma. So yes, it is definitely better to use Z for means if we can, if we know sigma. The problem is that in the real world we're not going to know sigma, and so it is very, very unusual that a problem will be on the AP exam that will require you to use Z for means. In fact, they won't ask that on a free response. Now, I did notice that on the in the pink book there is a multiple choice question where they want you to use Z for means, where they're telling you what sigma is. So you do need to be aware that it's always better to use a regular normal Z standard normal distribution if you can, but that's not going to happen most of the time. So that answers that question. The second question was, how is the confidence interval, the confidence level, the margin of error, N, all those things related? And this is a great question because it comes up a lot as far as what could I do, what could I change to make this a smaller interval or a larger interval. And so if you think about it, like the example, the Calvin and Hobbes with weather, I can be maybe 100% confident that the temperature tomorrow is going to be from 0 degrees to 100 degrees. Yep, that's very, very likely. I can be very confident that's true. Now, once I make that interval smaller, from 30 degrees to 50 degrees, I might be less and less confident. So confidence level, 95%, 90%, 80%, is going to move with the interval. The smaller the level, the smaller the interval. But even more importantly, that margin of error, how far you are from the center proportion is the center of mean, is going to also make a difference with your level. So if your level gets smaller, your margin of error is also getting smaller. So here on my picture, I have a margin of error of plus or minus 9 on either side. And so of course if I made that margin of error 8, it would move in, and my probability here, my confidence level of 95 would move in. So how is that margin of error affected? Well, as you can see by these two formulas for Z or T for means, a margin of error will move inversely with the sample size. So if the sample size increase, the margin of error decreases, and vice versa. So if you want your margin of error to decrease, which is always better to have a larger sample, therefore you have less error, but you still have the same amount of confidence, you can increase your confidence relative to your interval. And of course you can also change standard deviation, but that's pretty impossible to do. And you can change your Z and T, because Z and T of course come from your intervals. So again, the larger your interval, from 95% to 99%, your Z score or T score will be larger and therefore make a larger interval. So to kind of summarize that, to make a margin of error smaller, you can make your Z smaller, which means you have to lower your confidence. To make N, or you can make N bigger, which will of course cost more. It's harder to make a larger interval. So intervals, levels, and margin of error all move the same way. N moves the opposite way. That's kind of a good way to remember it. If you know a particular confidence level and margin of error, you can solve for your sample size. Now, we solved these equations using a proportion, but we did not do one with means. And so no, if you're doing it with means, you can't use T, because if we're solving for n, we'd have to know n to be able to use degrees of freedom. So we're just going to be extra conservative and put our z in instead of a t, as if we have a large sample size. So no, we'll do one like that on paper in just a minute. Okay, my next thing I wanted to really quickly mention, a couple people, Abby and Madison, on your Google form that I got in, it asked to interpret the confidence interval and the confidence level. And the confidence interval was, we are 95% confident that the true mean of whatever lies between this number and this number. And most people got that. Please make sure, some of you wrote 95% sure. Don't write words like sure or probability is 95%. It's safer just to leave it at 95% confident. But some of you did not write how to interpret the level. Several of you did very, very well in interpreting the level. And here it says a confidence level C, which gives the probability that the interval will capture the true parameter in repeated samples. And y'all did a pretty good job in saying that, that in repeated samples, 95% of the intervals calculated in this manner would find the true mean, would capture the true mean, and then put it in context. So don't forget the difference between, very important, confidence interval and confidence level. When your conclusion on a confidence interval will always be, I am 95% confident, and then it'll be about your interval. You don't have to interpret the confidence level unless you're asked to. That's not about your interval. It's not about you. It's about all the intervals, 95% of all intervals. And here's the picture kind of going through what we did in class, how all the different intervals, and every now and then there's one here that isn't capturing the true mean.